We've got a special guest lecturer for this video. Alex Fred Ohala will cover the very broad question of what is machine learning. He is an expert in AI and data science applications with tons of experience in the field.
Thank you so much for that introduction, Sean. And hello everyone, this is Alex. Now, in today's presentation, we are going to cover essential terminology related to machine learning. We're going to talk about 3 different categories of machine learning algorithms, and we will also cover the history of artificial intelligence and the 4 key enablers of the current deep learning revolution. I hope that you're truly excited, because now we will jump into the presentation. So, we will start this presentation by defining what machine learning and artificial intelligence really is. And we will also talk about why these concepts and terms are so important and why they have gotten so much attention over the recent years. First of all, every non-technical AI presentation usually starts with a quote like the one that you can see on the slide here. This specific one comes from Sundar Pichai. So he is the CEO of Alphabet and Google. He has said that AI is one of the most important things that humanity is working on. And he even thinks that it's more profound than both electricity or fire. Now, it has almost become cliché to say that AI is a greater invention than electricity or fire, or the automobile, the airplane, etc. People also like to claim that data is the new gold or data is the new oil. Basically, that data is the most valuable asset that a company today can have. However, there is a reason why experts like Sundar Pichai and other people with him are hyping AI this much. And even though these expressions, these statements, they have become cliché today, in every cliché, baked into them is a lot of truth. So if we try to unpack why Sundar Pichai, for example, would claim something like this, then I would like to frame it in the way that artificial intelligence now is intelligence that we are creating that is external to us humans. So in order to truly understand what artificial intelligence is, I think we need to define what human intelligence is. And now, bear in mind, this is not something that is easy. Scholars, neuroscientists, philosophers have all debated for centuries on how to define human intelligence. I'm not going to jump into that debate, but I'm going to give you kind of my quick take on what I think are aspects and traits that relate to human intelligence. And you can see them here now on the left-hand side of the slide. So I would say that human intelligence relates to our ability to solve problems, and also our ability to be able to set goals for ourselves and then also achieve those goals. Also that we as humans, we can analyze and reason about specific situations, also about the past, the present and the future. We humans, we can communicate with one another, we can collaborate on tasks, and we can also influence one another in order to make decisions. And this has led to the creation of societies and civilizations. Last but not least, we humans are also conscious. We have developed a consciousness and we are aware of our own existence. We can reflect on it. We also have emotions, we might be able to feel some sort of intuition, and we have developed an imagination, and we have creativity, etc. All of these are traits and aspects that relate to human intelligence. Now, if we turn to the right-hand side of the slide, again, there is no generally accepted definition of what artificial intelligence really is. One of my favorite definitions is the one that you can see here. So I would like to say that AI is the ability for machines, systems, models, computers to be able to simulate and even enhance aspects of human intelligence or intelligence overall. AI today is really good at solving specific problems in well-defined contexts. To some extent, these algorithms can also analyze and reason about situations. They can communicate with other models in order to make better decisions. However, AI today is far from having developed anything that can resemble consciousness. It cannot feel any type of emotions, but it's very much rule-based still. If we turn to a more formal academic definition of artificial intelligence, we can look at the work of Professor Stuart Russell and Professor Peter Norvig. They have written the classical AI book, Artificial Intelligence, A Modern Approach. In it, they define AI as the designing and building of intelligent agents that receive precepts from the environment and take actions that affect that environment. So it might be a little bit vague at first, but it's basically an agent that can perceive the environment and also take actions in a specific environment. Now on this slide here, you can see essential terminology and key terms that relate to the space of artificial intelligence. First of all, we have the broadest circle and also the broadest term, that is data science. A data scientist today is anyone who uses scientific methods and algorithms in order to extract knowledge and insights from data in order to make better decisions or predictions. A data scientist today could be an investment banker at Wall Street using data in order to develop new investment strategies. It could also be a software engineer at one of the big tech companies that is developing and deploying computer vision models. So data science is a very broad term. Basically, if you've ever used data in order to get some insights and in order to make better decisions, you can call yourself a data scientist today. So congratulations. If you've ever used a tool like Excel, you can call yourself a data scientist and you can update your resume. Now, a subset of data science is artificial intelligence. And we defined that on a previous slide. A subset of artificial intelligence is machine learning. Now, machine learning algorithms are a collection of mathematical and statistical models that learn representations from the underlying training data. Basically, machine learning algorithms extract patterns from input data in order to come up with the rules and the parameters of these models so that they can make smart predictions and decisions. A subset of machine learning is deep learning. Deep learning models are basically very complex machine learning models. They learn representations successively in layers. Deep learning is also the field of AI that has been the most hyped in recent years since the beginning of 2010. Now, another thing that I want to emphasize is that AI is not new. It has actually been around for a very, very long time. Even the mathematician Gauss, in the late 1700s, when he was solving linear regression problems and the ordinary least squares problem, he was in the space of AI because linear regression is a machine learning algorithm, and as we saw on the previous slide, machine learning is a subset of artificial intelligence. In modern times, we have had three distinct AI hype eras. The first one started in the 50s, then the term artificial intelligence was coined at the Dartmouth conference and workshop. We also had the introduction of the perceptron, one of the basic building blocks of a neural network. All of that happened in the 50s, and there was a lot of hype around cognitive machines and cognitive computers. However, many of these inventions proved not to be that useful. And we entered the first so-called AI winter in the beginning of the 70s when people started to doubt the capabilities of smart computers and cognitive machines and systems. The second AI hype wave started in the mid-80s, then machine learning algorithms and also symbolic AI and expert systems got a lot of media attention and a lot of buzz, a lot of hype around them. We created machine learning algorithms then that could, for example, categorize emails as spam emails or legitimate emails. We even deployed a neural network model, a convolutional neural network, in order to do handwritten digit recognition on envelopes and packages at post offices. However, again in the early 2000s, AI and machine learning didn't really live up to its full promise of what it was said to deliver to the world. So we entered the second AI winter. Right now, we are in the midst of the AI hype wave that many times is called the deep learning revolution. This started in early 2010, and I would like to claim that this is the true renaissance period for AI as a technology. So what are the factors that is different today? Well, I think that it boils down to the 4 key enablers that you can see on the slide here. The first factor is that we have a lot more data available today in order to train our machine learning models and algorithms. Approximately only in 2 days, we as a humanity produce more data than what we did up until the year 2003 in total throughout our entire history. So we have a lot more data in order to power these algorithms. However, in order to train on huge amounts of data, we also need very powerful computers. Therefore, we are very fortunate that, for example, the processing power of a CPU has closely followed what is being called Moore's Law. Now, Moore's Law states that the processing power of a CPU is going to double every 18 months, and we have closely followed that trajectory all the way back since the 60s. The third factor is that constantly we are developing new algorithms and approaches in the space of machine learning and AI. As a researcher in this space, I find it so intriguing to stumble across new methods and new capabilities almost on a weekly basis in research papers and from applications that have been developed by industry. The fourth factor might also be the most important factor, and that is that we have a broad public interest around this technology today. Governments are spending billions of dollars in order to develop AI R&D research programs, universities are setting up degrees on machine learning and data science, and only the fact that we are also creating this course speaks to the fact that there is a broad public interest around artificial intelligence and machine learning. Now, there are 3 main categories of machine learning algorithms and models that I quickly wanted to mention. The first 2 relate to supervised machine learning, and supervised machine learning is all about trying to find a function that can map some input data to some output that could be a prediction or a classification. In supervised machine learning, you need to provide data during the training of these machine learning algorithms that are correct input and output pairs. So you need to have the true outputs or the true labels associated with your training data in order for you to train these algorithms. Supervised machine learning algorithms could be regression models. They predict a continuous outcome variable, or it could be classification algorithms and models, and they predict or classify a certain set of categories or labels. We also have unsupervised machine learning. For unsupervised machine learning models, we don't provide any correct labels or outputs on the training data. Instead, we try to extract and parse patterns so that we, for example, could carry out clustering, dimensionality reduction, outlier detection, segmentation, etc. In order to summarize and conclude, I would like to highlight the difference between traditional algorithms and machine learning algorithms. So for traditional algorithms, and that could, for example, be symbolic AI or expert systems, the parameters and the rules of the algorithm would be decided by a human. Then data would be processed according to these rules in order to produce results and answers and outputs from these models. Machine learning, on the other hand, then the parameter values and the rules of the machine learning algorithms are decided during the training process. So in order to train a supervised machine learning algorithm, you only have to provide it with answers together with input data, and out would come the rules. These rules can then be used in order to predict answers and output on data that it hasn't been trained on before. If it has good performance on this task, then we say that the machine learning algorithm is generalizing really well. So we have a training phase where we provide the machine learning algorithm with both answers and some data. We train it, and out comes the parameters of the model, or the so-called rules. Then we can use these parameters and this trained machine learning model in order to get new input data that we haven't seen before, and that will provide us with some answers, some predictions, and some output. And hopefully it's really good. So that concludes this high-level overview of what machine learning and artificial intelligence is and why it's important. Thank you for listening.